So let's work on section 6.2, which is trigonometry of right triangles, which you definitely did in geometry, and you probably reviewed at least some of it in algebra 2. So let's look at this. SOHCAHTOA, remember that's the relationship between sine, cosine, and tangent and an angle. So relating to a right triangle, let me draw a little right triangle here, and then I'll fill it completely in a minute. So here's a right triangle. If you're referencing an angle that's not the right angle, then we talk about adjacent, opposite, and hypotenuse. Hypotenuse is opposite the right angle. If this is the angle I'm referencing, adjacent is next to it, and opposite is opposite the angle we're referencing. So sine of an angle is opposite over hypotenuse. Cosine of an angle is adjacent over hypotenuse. And tangent of an angle is equal to opposite over adjacent. And let's remind ourselves of the relationship between the sides of the two special triangles. So one of them, right triangles, has a 60-degree angle and a 30-degree angle. And you can write the relationship a different way, but I'm going to use the same values as we use on the unit circle. So if the hypotenuse is 1, because remember when we put it in the unit circle, this was the radius of the circle, then the short side is 1/2 and the long side leg is the square root of 3/2. Those are the same values as you find on the unit circle for 30 and 60 degrees. Let me also remind you about the other special right triangle. So this one has two 45-degree angles. So again, if we make the hypotenuse a length 1, then the two legs are the square root of 2/2 and the square root of 2/2, just like in the unit circle for 45 degrees. And now let's do some examples. So here's an example. Okay, we have a triangle with these side lengths. It's a right triangle, and we're referencing this angle theta. Definitely matters which angle you're talking about, and we want to find all 6 trig values. So I'm going to go in order of sine, cosine, tangent. Sine of theta is opposite over hypotenuse, so 3/5. Cosine of the angle is adjacent over hypotenuse, 4/5. Tangent of the angle is equal to opposite over adjacent, so 3/4. And then we have the reciprocal functions. So cosecant is the reciprocal of sine, so that would be 5/3. Secant of the angle would be the reciprocal of cosine, so 5/4. And cotangent of the angle is the reciprocal of tangent, so 4/3. Pretty straightforward. Another example. Let's solve the triangle. Solve the triangle means find all the missing sides and angles. So here's one. And this one will be a special right triangle. So this angle will be 30 degrees. This length is 12. And we have 2 missing sides here, B and A. And I'm going to label the angles as well. So this is angle C. This is angle A, and this is angle B. It's a understood system that we label an angle with the same letter as the side that's opposite, and the capital letters represents the angle and the lowercase letter represent the side. So there's more than one way to do this, but I'm going to show you how to do it by making a proportion. So let's work on side A here. Actually, I take that back. Let's find angle B first. If this is 30 degrees and that is 90 degrees, you take 100 minus 90 minus 30 and you get 60. So we found that angle. All right, now let's work on side A. So I'm going to write a proportion. So this is the hypotenuse of the special triangle. And that's going to be proportional to the hypotenuse of our triangle. So this is hypotenuse over hypotenuse. All right. And then I have uh, I have my short side here. So since the numerator's representing the sides of my special triangle, this I'm going to use SS for short side. The short side of my special triangle is 1/2. And the short side of this triangle is A. And now we just solve the proportion. So A times 1 equals 12 times 1/2. So that equals 6. So that's the value of A. And now we need to find B. So let's do the same thing. So I'm going to do hypotenuse to hypotenuse again. So hypotenuse of my special triangle to hypotenuse of the triangle we're working on. And then I have the long side. So long side to long side. So long side of this triangle is the square root of 3 over 2. And the long side of this one is B. So now we solve 1 times B equals 12 times the square root of 3 over 2. So that would be 6 square root of 3. So we found B. We found all the missing pieces of the triangle. All right. Here's one for you to try. Okay. So pause the video, take a minute, and find all the missing sides and angles. And when you're ready, unpause the video and verify that you got the right answer. All right, so now let's put some definitions down. Line of sight. If an observer is looking at an object, then the line from the eye of the observer to the object is the line of sight. 2 more definitions. The angle of elevation is defined to be the angle between the horizontal, so horizontal lines go across the horizon, and up along the line of sight. And angle of depression is defined to be the angle between the horizontal, again, horizontal goes along the horizon, and down along the line of sight. So let's draw a little diagram to illustrate this. So if I have my little person, my observer, and my observer is floating in space, which is a little weird. And here's a balloon flying up in the air that the observer is looking at. So this is the observer's eye right there. So we need a horizontal. So that's horizontal. And then between the eye of the observer and the object, so that's this line. So this is the line of sight. And between the horizontal and the line of sight, we went up. Therefore, it's the angle of elevation. So this is the angle of elevation. Now, if there was another object down here on the ground, maybe an ant, and the observer is looking down at the ant, okay, so between the horizontal from the observer and down, since this went down along the line of sight, then this angle is the angle of depression. All right, now we're going to do a couple of examples. All right, so here's the story. We got a giant redwood tree. It casts a shadow that's 532 feet long, and we want to find the height of the tree, and we know the angle of elevation of the sun. So let me draw a quick tree. Probably not what redwoods look like. And then it's casting a shadow, so that means the sun's up here somewhere, and the tree's blocking the light from getting to the ground. So this would be the shadow. And we know that the shadow is 532 feet. And then there isn't an observer in the story, but it says the angle of elevation to the sun. So we're going to put the little observer's eyeball there. And this is an angle of elevation up to the sun. And that is 25.7 degrees because the ground is horizontal. And then we're interested in the height of the tree. So we'll label that T for tree. And I have a right triangle here, assuming that the tree grows perpendicular to the ground. And we're ready to write a trig expression. So we have an angle and we have a side we know and a side we're interested in, and they happen to be opposite and adjacent. So that would be tangent. So tangent of 25.7 degrees is equal to opposite over adjacent 532. This is a calculator problem, not a special angle. So I know you can do this. There's a tangent button along the left, but make sure you are in degree mode before you do this, since the angle is given in degrees, and then type in tangent of 25.7, multiply it by 532, and you find out that it's 256 feet. Tall tree. That is a tall tree. After I did this problem, I had to go look it up and find out if redwood trees were actually that tall, and they are. All right, another example. So we have a point on the ground away from 500 feet away from the base of a building. An observer's looking angle of elevation to the top of the building. We got some information about that. And then we have more information about the angle of elevation to the top of a flagpole that's on top of the building. So let's draw a little diagram. So we have a building. And on top of the building, there's a flagpole. And there's an observer somewhere. And we know information about the angle of elevation to the top of the building. So that's from the horizontal up to the top of the building. And that was given to be 24 degrees. And then we also had information about the angle of elevation to the top of the flagpole. So that's not between this other side of the angle, but it's from the ground angle of elevation. So that angle is 27 degrees. And the other thing that we know is the distance from the person away from the building is 500 feet. So let's label the things we want to know. We want to know the height of the building, so I'll label that as B. And we want to know the height of the flagpole, not from the ground, but the height of the actual flagpole. So I'll label that F for flagpole. So let's start by finding the building first, because there's a nice right triangle here that we can use. We have an angle and the opposite and adjacent sides. So that's an easy tangent function. So the tangent of 24 degrees is B over 500. Type that into your calculator. Tangent of 24, multiply it by 500. And the height of the building is 222.6 feet. Now, yeah, one more thing to find. This little triangle here is not a right triangle, that little wedge, so that won't help me. So let's look at this bigger right triangle, because we assume that the building is perpendicular to the ground. So this is a right angle. Should have said that before. So we've got a 27-degree angle here, and we have the adjacent and something that makes it the opposite. So that would be tangent of 27 degrees is equal to opposite, which is this whole length, which is B plus F, over adjacent, which is 500. All right, type this into your calculator. Tangent of 27, multiply it by 500, and that gives you 254.8 is equal to B plus F. We're almost done. We know what B is. and then subtract, and we find out that the height of the flagpole is 32.2 feet. Great job.